Okay, let's do example 10 and 11 in chapter 4. It's on page 98. And this is a relative velocity. These are the relative velocity problems. And it says if the boat, a boat heading north crosses a wide river with a speed of 10 kilometers per hour relative to the water. The water in the river has a uniform speed of 5 kilometers per hour due east relative to the earth. Determine the velocity of the boat relative to an observer standing on either bank. So I like to establish my directions first of all. North, south, east, and west. Okay. And so it says that a boat is heading due north, across a wide river with a speed of 10 kilometers per hour relative to the water. So this is, oops, I didn't draw that very well. This is the velocity of the boat compared to the water. And it has a magnitude of 10 kilometers per hour. And we'll just say 90 degrees. Because I like to use the polar coordinates. 90 degrees is due north. And then it says the water in the river has a uniform speed of 5 kilometers per hour. So here's 5 kilometers per hour due east. So this is the velocity of the water equals 5 kilometers per hour at 0 degrees. And what are we trying to find? It says determine the velocity of the boat relative to the observer standing on either bank. So this will be just the velocity of the boat compared to our stationary reference frame, which is the bank or the ground, the earth, whatever. However you want to phrase that. And so this is a fairly simple problem, but let's go through it very clearly. The velocity of the boat equals the velocity of the boat compared to the water plus the velocity of the water. I always start there. That's like my basic equation. I say, what is my object called? Boat. I'll use the letter B. What is the stationary stuff? Well, it's just the ground. So I don't usually use a letter for that, but you can do it if you want. And then what is my moving stuff? Water. You can use river. You can use whatever you want, but I'm going to use W for water. So I do that. Then I try to draw a picture of it. And this one's pretty easy to draw. I just use this because I know these two, and these are the two vectors that I'm going to add together. I'm just adding these two. So it's the velocity of the boat compared to the water plus the velocity of the water. And that gives me my answer, velocity of the boat. So this is 10 kilometers per hour. This is 5 kilometers per hour. And so this is just the velocity of the boat. The magnitude of it is just going to be, well, 5 squared plus 10 squared. And I'm going to, rather than use a calculator, I'm going to cheat and look at the book. And so it's 11.2 kilometers per hour. Okay, that is my speed. Now, that's not my total answer, right? Because a vector has magnitude and direction. So let's figure out what the direction is. And so I'm going to use inverse tangent. And what I want to do is, what angle do I want? Do I want this angle or do I want this angle? Well, I want this angle right here. That's how I'm going to do it. So the angle of this is going to be the inverse tangent of the y stuff over the horizontal stuff. And so that's going to be equal to, let's see, also, you know what, the book did it the other way around, didn't it? That's okay. I'm going to do this, well, let's see, what would that be? inverse tangent of 2. And you get 63.4 degrees. So I could say that in polar coordinates, the velocity of the boat is equal to 11.2 kilometers per hour at an angle of 63.4 degrees. And if you want to put it in terms of like north, south, east, west, I would say it's 63.4 degrees north of east. And if you look at our silly textbook, I do believe that they drew a picture of it, and they give you this angle right here. So you would have to say that it's 26.6 degrees, but you have to say what that is. Well, that's east of north. Who uses that? I don't know. You can. If you say, by the way, on a test or quiz, if I gave you a problem like this and you said 26.6 degrees, but you drew a picture of it, you wrote down what it's respect to, like east of north or something like that. In other words, if you got it right, you'll get it right. Okay? So there's my answer to example 10. That's what I'm going to put. I'll have to follow the book every time. I'm not a robot. Okay? Now, now let's do example 11. And it says, and it follows on this problem, it says, if the boat of the preceding example travels with the same speed of 10 kilometers per hour relative to the river and is traveling due north, as shown in the figure, what should its heading be? Okay, so now we're getting tricky. So this is example 11 right here. Let's see what's given. So the velocity of the water is still the same. But now, here's what they give you. They say, it says, if the boat, it's still got the velocity of the boat compared to the water is equal to 10 kilometers per hour, but you don't know what this angle is. That's not given. In fact, that's what you're trying to find. The heading. How should you point the boat? What?
Number 10. It's 10 negative 5 over 10. Not 10. Sorry. What? Okay, the book's wrong. Sorry.
It's not wrong. It's just different.
Sorry.
The book and I, we just had a little disagreement, but we've agreed to disagree. All right. So we're trying to find theta. Now, here's what they give you information. They don't tell you what the velocity of the boat is, I don't think. They just tell you it's traveling due north. So this is what they'll do. Your unknowns will be in, look, over here, over here I should have done this. What is this? This has two parts to it, right? It has magnitude and direction. So there's really two unknowns here you got to figure out. Well, here the two unknowns are different. And let's see. So let's solve it real quick. Well, the bell's about to ring, so I'm not going to be able to, but I can draw a picture of it. Here's the velocity of my boat. Okay? I'm just going to draw a line like this. It's traveling due north. The velocity of the boat is equal to this plus this. So, are these the sum of these? So this one I know the velocity of the boat or velocity of the water is like this. So there's the velocity of the water, and then the velocity of the boat with respect to the it's going to be 10. So I don't know what that angle is, but I know this. I have to point my boat to the left in order to cancel out the rightward movement of the water. And so here's this and here's this. So here's the velocity of the boat. Here's the velocity of the water. Velocity of the boat compared to the water. Hey, complete that triangle, complete the triangle, and then you can figure everything else out. That is all.